Okay, it's time to talk about covalent bonding. This is my favorite type of bonding. It's a bond based on sharing electrons. I'm Dr. B, and let's go ahead and get started. Well, how does this sharing work? Why would they do that? Well, just like with ionic bonding, they're sharing electrons to obtain those full outer shells, which in almost all cases is 8 valence electrons. They don't have them, and they need them. So let's consider the electron dot structure of neon. It's really helpful to take a look at something that has a full outer shell. Neon has 8 valence electrons. Let's spread them out, 2 to a side. That's called a dot structure. And that's a stable guy. But if you take a look at, say, hydrogen, oxygen, nitrogen, carbon, which I choose because we're made out of that, about 95%, let's go ahead and do that. There's hydrogen. Oxygen has 6 valence electrons. We better pair up 2 of them. Nitrogen has 5 valence electrons. I'm just going from the periodic table here. It's in that fifth column. And there you go, 5 valence electrons. We better pair up 1 of them. Carbon has 4 valence electrons. We don't have to pair up any of them. And it's interesting to note that if you take a look, hydrogen forms 1 bond, oxygen 2, nitrogen 3, carbon 4. Maybe you've heard that before. Honk if you love chemistry. And that correlates with the lone electrons here, not the lone pairs, right? Those are paired up, but the ones that aren't paired up but want to be. So that's perhaps why they form that many bonds. And the number of lone pairs is none here. I see 2, I see 1, and I see none. Fine. So you look at those unpaired electrons, and it's a good approximation for bonding. We still haven't explained why they want to share electrons, though. I mean, can't this just gain 2 to form an oxide? Can't this gain 3? Well, it can, and nitrides exist, oxides exist, even carbides exist, but there's another way things can happen. If there's a fluorine next to another fluorine atom, well, I guess why doesn't it take one of those electrons and pull it away? Well, that will render this with a lone pair, but that would never happen to fluorine. It needs one. And so how is it going to get 8? Watch this little animation. If it makes sense to you, well, then you've mastered the principle of covalent bonding. Does that ring any bells? Do you see anything good happening? Well, perhaps these 2 circles will help. Look at that. 8 electrons there, 8 electrons there, 2 of which are shared. That's the line that you sometimes see, right? That line is sharing 2 electrons. Don't forget those lone pairs. And that's the principle of covalent bonding, a bond based on sharing electrons.